There's very few people who could fill a room this size with a talk about software design. So I suspect this is going to be an easy introduction to introduce my friend Hynek. We've known each other for about 15 years. Hynek's description in the bio says he's a lead infrastructure and software engineer from Berlin, Germany. He's a PSF fellow, he's a blogger. He hasn't mentioned this in the description, but he recently released a 40-minute video on YouTube about UV, which is desperate for people to watch, so you should really look that up. And he's the maintainer of way too many open source projects, including Atters, which if you haven't used it directly, if you've used data classes, that was inspired by Atters. So really sort of directly making changes to core Python itself, or indirectly perhaps. When we were watching the keynote, there was a quote that stood out to me that made me really think of Hynek, which is, "The cleverest people are wrong all the time." And I would really like to say that about Hynek, but sadly that's actually not really true. And over the years, I've learned to take his opinions very seriously, because even though sometimes I have quite strong reactions to them in the opposite direction, he turns out to be true over time. You may well have some strong feelings when you hear some of the opinions in this talk, but I encourage you to take them seriously, because on deeper thought, you will find some truths in them. So with that, it's my great pleasure to introduce my good friend Hynek with his talk on design pressure. Can we please give him a massive round of applause?
Levels. Wonderful. Okay. Dobré ráno, Praho. I'm Hynek. I'm a software engineer at a boutique German web hosting company called Vario Media. I was actually born here, so and I only learned about getting this slot like a week ago. So if I'm a little bit more rocky than usually, don't be surprised. But I had to jump on this opportunity to give one last talk at a place I was born. As Judy mentioned, I'm a very much burned out open source maintainer and a future famous YouTuber, although with every video it seems like it's a little bit further away in the future, but yeah, we will see. Like, you can be the original Hynek hipsters in this room. So I've got 45 minutes instead of 30 at PyCon US, which is kind of nice because it means I can breathe while talking and it won't feel as much like freediving. But let's get to it. So I'm here to talk about software design, and I'm here to tell you about pressures that affect your precious applications that you might not be aware of, and that's the key. But they affect your design, and they affect your design in ways that you might not like. But first, let's make sure that everyone is awake, and I hope everyone took their blood pressure pills. So, the use of object relational mappers and class-based validation frameworks ruins your projects. That was always meant like to be provocative, but I always get a huge round of applause when saying that. So, okay, cortisol levels are not that high as expected, but here we go. So in YouTube land, we call this an attention hook to stop people from closing the video as a sacrifice to the retention graph gods. And depending on whether you deliver on that hook or not determines whether you are a great filmmaker or scammy baiter. So let's see where I fall today. And we will start by adding a little bit of nuance. Django, SQL Alchemy, Pydantic, Marshmallow, they're all fine, as long as you're aware of what effect they do have on your code. And that's today's topic. But the concept of design pressure is not specific to this area. That's just my hook. I will also give you other examples that have nothing to do with ORMs, databases, or validation whatsoever. There will be something here for everybody. Because this is not a talk about tools. This is a talk about architecture. And therefore, I am not here to tell you to stop using your favorite tool. So you can relax. You can stop messaging Mike and Samuel. I saw he was not at the Pydantic store, so I'm fine probably. Django Software Foundation also does not know where I live, and I'm a good runner, so let's keep it in this room. So my emphasis is not on ORMs or validation frameworks, it's on the unreflected. And my goal for today is to make you aware of the trade-offs that you're making, and it's trade-offs that you're most likely doing subconsciously, which, as good old Carl Gustav already knew, is not great for you. Design decisions need to be deliberate, not a matter of, let's say, perceived fate. But to get there, we have to clarify one big thing. Why do we write software other than for money? Is it to access a database, or is it to validate some data coming in through a web API? I mean, someone has to write a database driver, someone has to write a validation framework, but otherwise probably not. Most people do not. You probably write software to achieve a goal using those two tools in this case. And the core logic that does that is often called the business logic. And as with everything in software engineering, there's a passionate discussion about what exactly is business logic. But this is my talk, my room, my rules, deal with it. And for me, it is the code that decides what to do based on data coming in from, for example, databases or some kind of user input. In my case, a web API, but it can be a file, it can be CLI arguments, it can be anything. And most importantly, business rules. And the term business logic, business rules harks a little bit back to the times where computers wouldn't fit into this room and mostly stood in banks. But your business might be also curing cancer or something more interesting like that. Business logic does not have to be about shareholder value, but it is always important. And sadly, in many cases, business logic is just a bunch of if statements that are buried somewhere in a web view or CLI endpoint, mixed up in form validation and database access. And this is especially true for tutorials that make you implement simple block engines or to-do apps, because they're teaching you a framework. That's their job. And they don't want to distract from that with complex out-of-framework logic. So thanks to that, many beginners haven't ever seen explicit business logic in their whole life. They don't even know this concept exists at all. And but it is like the code why an application ultimately exists. It is the code that can have grave real-life consequences to actual humans, like using the wrong radiation dose. I hope every programmer heard of Therac 25. Well, quick, who have heard of that? How many of you have heard of that from my talk and we're watching it for the second time? Okay, good, good, good. So Therac 25, very famous. It's a radiation therapy machine from the 1980s. And it's famous for having a race condition that caused some patients to receive 100x of the radiation they were supposed to get. So you can imagine what this does to our mushy bodies that get sweaty once it's over 40 degrees. People literally died of that. People died because we fucked up some code. And this can happen anytime. And maybe people won't die of radiation overdose if you screw up your business code, but it can still translate into real-world calamities, like the recent British post office scandal. Who knows about that one? Oh yeah, this is Europe after all. So, in a nutshell, a Fujitsu accounting software accused innocent sub-postmasters of stealing. 900 of them were persecuted for theft, fraud, and false accounting, which you can imagine if you become a sub-postmaster. Like stealing, okay, fraud, okay, but false accounting, man, that must go really to the bone. 236 of them went to prison. And the fallout on their private lives was even worse. Like, if I described to you what happened to some of them, I would be demonetized on YouTube. Like, this is a huge tragedy. And fortunately, that's one found out. Fujitsu, of course, is innocent, but the damage is there. So business code is the most important code of your application. And you have the moral imperative and self-interest to make it as correct as possible. And that's where design pressures come into play, because it can make your job easier or harder. And I've encountered this term for the first time in J.B. Rainsberger's seminal talk, Integrated Tests Are a Scam, or Integration Tests Are a Scam. He has been giving the talk for like a decade, and it's changing a little bit, but it's a great talk, so he should keep doing it. And he talks about how growing the scope of a system under test, so for example, instead of testing just a function, you test the whole class, or the whole module, or the whole service layer end to end. That if you do that, you will limit the design feedback from your tests about your code. In other words, it's masking the pain of bad design. In other words, you get away with tangled, highly coupled code because you don't feel the pressure in the form of pain, the pain of testing coupled code. So what exactly is coupling? Two pieces of code, for example, classes or modules, are coupled if they only can be used and understood by looking at both. Usually it also means that if you change one, you have to change the other one too. And coupling makes it harder to test, change, understand your code, which are kind of important properties if you're in there for the long haul. I mean, 10 years ago, nobody was, because we changed jobs every 2 years because we got a raise, but that times are over. So maybe more of us are in there for the long haul. And we care about maintainability of our code, because it's us who's going to have to understand the code in 5 years. And you shouldn't have to understand the intricacies of an ORM or Cthulhu forbid a web framework when you're trying to understand the logic that decides on the amount of radiation that is going to blast it at a human being. And since all of us are writing tests the whole time, we get the feedback that our code is too coupled from the get-go. Because writing tests for coupled code sucks. So you don't have to wait for design feedback until you need to add a feature a few years down the road, or when you are hectically trying to debug some code because something terrible happened and you might go to jail. So at this point has been made many times before. Testable code is better code because it forces decoupling of your code on you. And while there's the concept of so-called test damage, which is complexity in your production code that only exists to facilitate testability, it's clearly too much of test damage is bad too, sure. But overall, like, testing is a force of good, and it is our first design pressure of the day, and it's a good one. Having to write tests without monkey patching and mocking half of the universe leads you to less coupled code if you listen to the pain. Because otherwise, it is very painful. And that directly makes your code easier to change and understand later. So this is the good one. And in fact, I've heard the argument before that the main function of writing tests is specifically the design pressure for better software. And the tests themselves are just like a nice side effect that you just don't throw away now that you have them, but they're not that important. And I wouldn't go as far, but returning to a project after a year that has like 100% test coverage feels very different than coming back to one that does not. So I really love my tests, but they've got a point. Like, this is much bigger than the concrete thing that the tests provide to you. Now, I hope this part was relatable to everyone, because it doesn't matter what kind of you write, you should test it, and you should listen to the stability pain. And acknowledging the pain and letting it guide you instead of claiming that you are the one snowflake that writes code that can't be tested will improve everyone's life here. So, pain, in this case, good. Next, let's look at the design pressure that's neither good nor bad per se. And I'll use a great talk I saw at PyCascade 2024 to illustrate it. It's called The Rising Sea. In it, Matt Drury shows us a very elegant solution to a problem from advent of code, our beloved tradition of vowing to use it to learn a new language, usually Rust or something really obscure, and giving up on day 6 because, surprisingly, this year too, life is too stressful. But next year is going to work out. We're all going to sign up again. So he frames it as a conflict between two mathematicians, and I'm not going to tell you which ones, because I recommend everyone to watch the video. It's a lot of fun. You will learn a lot. So I will only spoil the professional part, not the fun part, so you can still watch it. So in this case, the exercise is that your input is a harbor, and a harbor consists of boxes. So the letters in square brackets are boxes. They are stacked on each other, and each stack has a number from 1 to 9, okay? Now, then you have instructions telling you what to do with those boxes. For example, move 5 boxes from stack 4 to stack 9. And then, channeling one of the mathematicians, he gives himself a design maxim. No, that was too far. Sorry. There, design maxim. You should structure your data so that the problem solves itself. You should structure your data so that the problem solves itself. And then he goes off to do just that and models the problem using nice, clean classes. An instruction class that encapsulates a move, a harbor class that consists of stacks and executes instructions. And finally, a stack that consists of boxes and allows you to add and remove boxes to and from the top. And the boxes themselves, they don't matter at all. It's an abstraction. It could be strings, it could be objects, it could be anything. Like, the problem here does not solve what's in the boxes, just like a crane in a harbor does not care about what is in a box. And so these classes combine the business logic of harbor box management with the data structures that work on it. And this makes it a domain model. And in software engineering, a domain model is a conceptual model of the domain that incorporates both behavior and data. That's what we've just seen. A conceptual model in Python is just a very fancy word for a bunch of classes and how they relate to each other, how they interact with each other. And a domain model tries to reflect the domain in which you're solving your business problems. In this case, a harbor. Meanwhile, a data model is something completely different. It's for all intents and purposes a database schema. And annoyingly, it sounds almost the same, because one of the biggest sins of software engineering is the constant reuse of terms. It feels like all important concept names are somehow a combination or permutation of the terms model, event, domain, and service. And don't get me started about working at a web host that registers domains and runs services. It's great. Anyways, this is your precious, the domain model, no matter how small, and it tends to be small compared to the overall size of the application, is the reason your application actually exists. The rest can be as shiny as it wants. If you screw up this, your application is worthless, or even worse, it does damage. And coming up with a domain model is called domain modeling, and obviously the chances to not screw it up are much better if you think of it as an explicit separate step. And the quality of a domain model is a function of how well it reflects the domain. So that makes it a very good idea to do that with domain experts, who are maybe not programmers, but understand harbor box management in this example, and how understandable it is. I think Matt's code delivers on that quite well. It even fulfills the Platonic ideal of a domain model by being completely isolated for everything that is not part of the domain. So it doesn't care about what's in the boxes, it doesn't care about how to move. On one look, you can identify the entities that exist and their relationships and understand the business logic they implement. Like, it doesn't even need conditionals like if statements, which is always a good sign. So we've got this pretty cool domain model that's just a bunch of classes that implement your business logic without knowing how they got created or how they persisted. But then, as a plot twist, he shows us more code, which he calls the darkness. This code is necessary for the elegant code from before to do its work, because it parses the input, which we get from advent of code, and munches it into nice and clean harbor objects. So please don't try to read or even understand it. I've counted like 6 for loops alone. That's way too many for loops. So this code has nothing to do with a problem domain at all. And the actual crane moving code only gets to be elegant because it knows nothing of this filth. Also, the format that's coming in can change any time. But the domain logic, the important part, will probably not. And you should be able to change those independently from each other. So this is kind of a buffer between the data coming in and the business logic. And so Matt concludes that the shitty stuff should happen on the outside layer of your program that interacts with the outside world. Once it's inside, organize it into nice data structures so that operations, i.e. code, are as self-evident as possible. Now this is the key lesson. It's another way to say validate at the edges. And he goes a step further and says to reshape your data at the edges too into a shape that serves your problem that you're solving. So this buffer between the layers that I mentioned, it doesn't have to be a parser that you wrote yourself. It could be a parser that Samuel Colvin wrote. It can be some abstraction over a database. The important part is that you get beautiful harbor objects out of it. And yeah, it's important that you take agency over the code, over the data that you work with. That's the important part. How you get there, that's your thing. And what follows from all of this is that the shape of the data determines the shape of the code. And that's a design pressure right there. If he'd mixed parsing with executing, which would 100% have happened if he just started coding away, his code would be much worse, and the business code would be much harder to understand or even find between the 6 for loops. But Matt removed the pressure completely by converting the input into something that is well suited to his task at hand. So the business logic is completely decoupled from the parsing. And again, that's a good thing. Like the shape of the input, you do not have control over. So you should not have an influence on your code that you have influence over, the business code, the important part. So as promised, there are still no ORMs or validation packages near and far. This is relevant for every single one of you. But with that in mind, let's do talk about ORMs and class-based validators. And first, they tend to call their classes all models, which is fair enough. I've said before, there's only 5 terms we are allowed to use to name things in software engineering, so there we go, another model. But those models have a widely different design goal. Like those 3 types of models have widely different design goals from each other, and those goals are actually conflicting with each other. So the shape of the validated data is dictated by the shape of the API, which is shaped by what is ideal for the users to use, not for you, for your users. And maybe by what API best practices are telling to you, like JSON API, or what you're going to steal from another popular API that you really like. What people want to post is usually not what I want to work with. And some call this is an external model, for obvious reasons. Now, the shape of ORM models is dictated by the shape of the data model, aka database schema, aka table design, whatever, with various levels of adjustment power depending on the ORM. Especially SQL Alchemy has a lot to offer to munch table data structures into something very convenient. Django's ORM, a database schema has very different design considerations than an API schema or a domain model. For SQL databases, there's always the tension between performance, normalization, redundancy. In old school companies, they are even designed and maintained by dedicated, usually grumpy DBA teams that don't care about your business code at all. Like they care about indexes and dead tuples and these kind of things. So obviously, this is a very internal model, and maybe phrasing it like that already starts lighting up some light bulbs. Like, should the internal and external models really match? Is that a good idea? So finally, the domain model. Ideally, the only thing that it cares about is the shape of the problem that it's solving, nothing else. So this is obviously an internal model too. Your users do not care how you solve their problems as long as you do solve them and do solve them correctly. And since it's the most important code in a project, you ideally want to get all the help that your language and ecosystem have to offer for you so you get it right. Like making illegal state unrepresentable or static typing is great. As Lukas told us a few years ago, it's a design pressure on its own. And that gets really difficult with, for example, Django's ORM, the moment you don't want to overfetch data and use model.objects.values that takes strings and to choose the columns. And you cannot hope to ever get that type safe. Like, there's no way from strings to types. And if you don't think overfetching is a problem, I had a breakfast with a Django adjacent friend the other day, and he mentioned that some of his coworkers found out the very hard way that there's a limit on 1,664 columns in a Postgres query. This is what you get with careless joins and not limiting the columns that you actually need. There was probably some recursion there too, but this happens. Like you have to be careful about what you ask the database for. Now, my business code also needs different kinds of information depending on the state that an entity is in. For example, when dealing with open, overdue, and paid invoices, I'm interested in different kinds of data. Like when dealing with open ones, I want to know when they're due. When dealing with paid ones, I probably care about when they've been paid. And finally, when dealing with overdue ones, I start caring about how long they've been overdue and how much reminding has been done to them before. And one reason why people get so itchy is because these classes, they look so similar, right? Should it be really 3 classes? They're so close. It's so... But as Sandy Metz so wisely said, a little bit of duplication is far better than a wrong abstraction. And I mean, we have a way to share these kinds of similarities, either by subclassing, which in this case would be specialization, which I gave you the blessing 2 years ago to do, or you just use composition. There's ways to avoid duplication, but cramming everything into one object is not it. Like, especially when dealing with overdue invoices and deciding whether to start debt collection on real people, which has real consequences. The focus shifts completely. You're still looking at the same data coming from the same source, but you're interested in a different perspective on the same data. And you probably need to enrich the invoice data from other sources too. So you need to compose your ORM models or even call a third-party API. So the question is not what attributes an entity could have or what we need to store. The question is, what do you want to do and what do you need for that? And since this code can have devastating consequences, I want my business logic in there to be as straightforward as possible and my data structures as clear as possible. I certainly don't want like one generic big blob full of optional fields here. Like having classes with a lot of or none type annotations is one of the biggest design smells there is. And again, some packages offer ways to make this problem less severe, like tagged unions, table inheritance, field aliases. Those things exist, but they are underused, strictly advanced features. They usually still fail on the last mile when things get more complicated, which is where they'd be most important. So, what do people usually do when they deal with this conflict? So the most common bad approach is that depending on your preferences, you pick the web API or the database schema, but never the domain model as your primary model, and let the rest conform come hell or high water. And when starting with the database, which is like the old school way, before we had these fancy validation frameworks, there's even a name for that. It's database-driven design, which, by the way, is a pejorative. It's not a best practice pattern, please. Either way, it means that you're starting on your back foot when implementing your business logic on what essentially is raw data and or a web API that allows me to guess your database schema and or a database schema that would make anyone with a background in database design take up goat farming. So this is the middle bad case. Let's talk about the worst one. The worst case is that you balance the needs of the web API schema with the needs of a database schema. Maybe because you want to use the same models in both cases, because you thought that's a good idea. There you already get mediocre results, because it's a compromise between two competing design paradigms, like different needs, as I've said before. So, foul compromise. Now, you force that foul compromise on your domain model, meaning it's impeded not by one impedance mismatch, but by two. And this right there is the reason why I find the combination of ORMs and class-based validation packages so unholy, because the domain model that is foundational for the quality of your business logic is squeezed between two layers with conflicting goals that lure you in with convenience, promising the dream of a unified data model across all layers, and the result of the dream is more of a nightmare, at least to me. If the shape of the data shapes code, weirdly shaped data shapes your code in weird ways. And it can't be anything but weird, given it's dictated by a compromise already. Like, you're not getting the best stuff. You're already compromising, and now it's going to even affect a third layer. So, again, this is not the fault of any of those tools on these slides or any other. This is not a tool problem. This is systemic to trying to force a unified model on layers with conflicting goals. But wait, it gets worse. In theory, with API versioning, we can change web API details anytime we want. In theory, with database migrations, we can change the database schema anytime. In practice, they calcify the shape of the already imperfect data because changing web APIs angers your users. Every one of you is more likely to have to re-implement an existing API with a horrifying schema, but that others are depending across the company, than design your own. And database migrations are still tedious and problematic, especially under load. And in my experience, and what I've heard around, is that the circumstances tend to lead to a loss of control over your tables if you ever had them in the first place. So, and given that greenfield projects are super rare, that's like the biggest lie we tell like CS students and everything, like you almost never get to work on a greenfield project. This means that you almost never get to design those models. And if you get this to the logical conclusion, if you let this happen, you have lost control over your domain model, and since the shape of the data shapes the code, you've also lost control over your business logic, and that is very bad. And while this topic was marinating in my head for like 2 years, one Adam Montgomery wrote a blog post entitled How I Built, which refreshingly, despite coming out in 2025, was not just AI bootlicking, and it had this killer passage that matches my experience and that I found very liberating. It's okay to have duplicative-looking types for different layers of a project. For example, ORM, API schema, and business logic. Types need to be easy to change and reason about so we can adapt them to our evolving requirements. Types near the edge, like API schemas and database tables, are inherently less flexible. See previous slide. It's often better to explicitly map types between these layers rather than create a Franken type and allow the least flexible layer to calcify the rest. Wow, like this is my talk on one slide. It was almost spooky to stumble over it while I was thinking about all this. Like, map types here means convert to better types. So what he's saying is that you should be okay with having 3 classes for the same thing, depending on what you're doing with it. And I'm gonna add, it's okay to have even more than 3. Now, who wants to see an example? Yeah, everybody. So I will try to show you something, but as Kent Beck once wrote, good examples are by far the hardest part of explaining design, because we usually can just take something from prod, because A, copyright and getting fired, and B, they usually only make sense in the context of a larger system, so it's not very helpful to put them on a slide. But let me try anyways, and use something very banal, and it's international postal addresses. So, given that there's countries where a postal code is enough to receive mail, like Ireland, which in 2015, after being the last country in OECD to not have postcodes, decided to go all in. And given that there's countries that don't have postcodes, which I'm sure is part of Ireland because there's always someone who will refuse to use postal codes out of principle, every field on an address is optional. Now, this is not a domain model, this is a data model. Just add an ID and you've got yourself a wonderful database table. But this is not useful when trying to write any kind of business logic around this or trying to validate incoming addresses in the first place. So you see there's like the tension between all 3 layers here. It tells me nothing about the concept of a postal address. I could use a dictionary here instead of a class and I would lose nothing except easier typing. Now just imagine trying to add any kind of behavior to this class. You either end up in a quagmire of if-is-none statements, or you end up doing some kind of dispatch on the country field, but you still have to fight the type checker, because as far as the type checker is concerned, everything can be none. So, assuming you're writing code where the shape of the data matters, for example, formatting addresses, which decidedly is not business code, but it's an easy example where it does matter, for like printing on envelopes or something, you can hide the different valid shapes somewhere in the code, in a Rube Goldberg machine of if, none, and match statements, or you make the shape explicit and define them like here for the US of A. Looking at a US address, you know exactly what fields exist. A function that takes US address as an argument knows exactly what it's getting. It's defined in code and can be validated by MyPy, by TY, or whatever checker is the best one right now. And you can use all fields without checking first, except for either 2. And to be clear, there totally are ways to get this out of a Pydantic model. You just have to know that you want it, and you need to know how to do that. And also, small, by the way, you can totally pass 6 arguments to a function. Nobody's gonna stop you. Arguments that have the correct type annotations. So if you know the country is US, you call this address. So you will have to add 1 type ignore on that when calling the function. But then inside of this function, which is presumably important, you can again rely on your type checker. And you know that everything is valid except for either 2. So, the aforementioned buffer between your business code and the outside, as you can see, it can be 1 function call with a type ignore. It doesn't have to be some fancy thing with 6 loops around it. It's just a matter of thinking strategically about getting good data into your behavior. So, What am I actually suggesting if it's not to ditch all your tools? In the ideal virtual case, I want you to start with the domain model. I want you to understand the needs of your users and give them the best possible experience, whatever the interface is, CLI, web, whatever. Think of the users, give them what they want. I want you to understand the optimal shape to store and retrieve the data, which has nothing to do with what your users want. And I want you to accept the conflicting goals between all those three layers and to adapt the data to its optimal shape for each case, understanding there might be more than 3 shapes. And in the case of a database, this could mean applying the repository pattern that uses the convenience of an ORM to build database queries, but spits out neat and clean data classes with encoded state and nice types, with as few optional fields as possible. And that are also decoupled from the ORM, so there's no I/O, which makes them very easy to test. In the case of a web API, it can mean that you use Pydantic's tagged unions to receive narrowed down classes with tight typing constraints. And yeah, so you know what you're having there. But of course, as you maybe noticed, we don't live in an ideal world. And this is software engineering, which means it depends, of course, it depends. And we are talking trade-offs here. There's plenty of cases where an application would consist like 90% of data conversions, which is not ideal either. Maybe your web service is a pure database lookup thingy. Like I have exactly one of those in production too. Its name is literally lookup service. And there, the most important logic is not some business stuff. It is the mapping of web requests to queries and enforcing authorization rules. In this case, I don't care about the shape of the data because I don't use it myself. I just pass it through to a JSON endpoint. So the perfect shape for this data is actually a dictionary. So I'm emphatically not saying that you should replace your ORM with raw SQL statements and data classes. You will run into the same problems eventually. I'm saying that you should focus on what you need to do with the data, with what data and what shape of data is ideal for what you're trying to do. And effectively, this means that you end up with better SQL queries too, whether you write them by hand or not. But you will cut a lot of waste. But you definitely need to start with the domain model because you need to understand your problem domain, like the harbor in my example. You need to understand what your software is supposed to do. Because if you want to compromise, you have to know what you're compromising on. But then, when you know what you'd like to have, you do start to compromise. But you're aware of what effect or design pressure it has to pass a Pydantic or ORM object into your business code. And then you decide, is the convenience worth it or is it not? You can compare the performance trade-off between mapping data into a better shape versus implementing algorithms on top of suboptimal data structures. If you have to make 4 dictionary lookups and 1 full list scan per loop iteration, your minimalism has gained you only a lot of square brackets and a hefty performance penalty. And finally, and crucially, you can look if the tools that your ORM or validation framework ship with can be used to shape the objects closer to what you like to have if you can't have it outright. But for that, you need to know what you want. And I want you to do all of this conscientiously and to know your options so you don't call the result fate. So as you've noticed, at no point did I suggest that you should abandon your beloved tools. Your tools are fine. I'm not here to take them away at all. I'm here to make you conscious of the hidden pressures those tools exercise, especially when combined. Like ORMs have been called Vietnam of computer science in 2006. And now it has a buddy that raises the problem to a higher power. We need to be aware of that. So I'm here to make you aware of the conflicting goals, of the at least 3 types of models, and their siren song to paper over the tension and conflicts with accidental complexity, which is complexity that is not inherent to the problem you're solving and therefore making your business codes strictly worse. And this is pretty much the definition of an attractive nuisance. Things look great on slides, and non-trivial code actually does fit on slides. We want that too. We want this compact code. But they couple things that don't need to be coupled. They add complexity to critical code that doesn't need to be there. And all that just to save a few lines of trivial code to avoid precise modeling of your problem. And therefore, the design pressure is coming from the most dangerous place, the most human trait ever, our laziness. Laziness can be good. Laziness can be excellent when it makes us automate repetitive things. But laziness also leads us to paper over impedance mismatches with a bunch of if statements. This is the wrong type of laziness because we are taking shortcuts to avoid having to represent entities in more than one shape, avoiding to press more keys on our precious mechanical keyboards. But we pay for that later by having a lot more code paths to test and consider. Like every if statement literally doubles the number of possible code paths. This is exponential. And since 2020, we know exponential is bad. So every new code path makes your code harder to understand. We pay for it by having awkward data structures in places that matter. We pay for it by dealing with business code that is somehow coupled with cached implementations. And yes, I've seen that. And we pay for it by not being able to adjust our data structures to a new understanding of the problem you're solving. And this is a very important thing, to be able to refactor towards understanding. And this makes proper design a delayed gratification, which humans are famously bad at. And what annoys me most is that we try to label this behavior as a virtue by calling it simple. Because when I talk about simplicity, I don't talk about how to save key presses. I mean, good Lord, Claude Code can press keys for me while I'm making coffee. When I talk about simplicity, I talk about how to save my sanity in a week, month, or year. Because writing complex software that has fewer lines is not simplicity. Using only structures and patterns that are within our comfort zone is not simplicity, it's easiness. That is falsely labeled as simplicity, so we get to be lazy while sounding virtuous. But there's a huge difference between easy and simple. As the inventor of Clojure, Rich Hickey, explains to us in his seminal talk, Simple Made Easy, that I rewatch at least once per year. Easy is not about the number of things, but about how interleaved or coupled they are. Using raw dictionaries instead of proper classes is not simple. It's familiar. It's easy. It might even be faster. So it might be a possible optimization, but it's not simple. Using poorly designed God classes so you don't have to write more than one, so you end up with a highly coupled ball of mud, is also not simple. It's easy. And so on and so forth. Simplicity is the result of hard thinking for delayed gratification, like the harbor example I've shown you before. Easiness is the result of going the path of least resistance, whatever it means for you. So whenever someone is lazily throwing around aphorisms like keep it simple, you ain't gonna need it, or don't repeat yourself, like what crimes I've seen committed just to not write a line of code twice. It's crazy. So hold on for a second. Is this person actually pursuing simplicity, or are they just being lazy? Are they shooting down things they don't fully understand? And the complexity bill comes later. It's easy to parrot pearls of wisdom. It's hard to have earned opinions. So where does all this leave us? Your business code is important, but if you haven't put any thought into it, it's probably buried somewhere between form validation and database access. Go and find it, and make your data structure serve it. Maybe try out domain modeling. Try out the very related Sans.io in a toy project so you get a feeling for this kind of thinking. Keep your tools are cool, but try to decouple your business logic from them, learn them properly, find ways to limit their design pressure on your code. And finally, writing tests will make your software better. Stop monkey patching, as Brandon Rhodes wisely quipped, is software bankruptcy. So let the pain guide you to less coupling instead. And that's all I have for you today. If you want to go deeper, this link will take you to a collection of articles, books, and videos, and of course, the slides that someone already asked for before I even started talking. As you can imagine, this is a wide field, and if you just got this stupid joke and therefore speak German, kauft eure Domains bei Vario Media. They pay my way here, they leave me the time to do things properly, and they allow me to share my findings. Follow me on all the socials. Nowadays, it's too many to put on a slide, so just go to my homepage, pick your favorite. Finally, if you like my sexy Czech German accent and want more of it, like and subscribe my YouTube channel. I'm very slow at publishing, but people seem to like it. And I'm only roughly 7 million subscribers away from CGP Grey. So I've run out of time, but I'm always happy to chat about these kind of things. I'll be around through Saturday, and I'll be at a social event to you. So with that, I'm Hynek. Thank you very much.